probability of the distribution. That model will misclassify a random selected example from the point. In this estimation of the hypothesis, we are using the two different type of the error. One is the sample error and true error. Now, the more mathematical information about the sample error, it is denoted by the error of the sample of the hypothesis H, the error of sample S of H of the hypothesis H with respect to target function F and data sample S is the error of the sample of H is equal to 1 by n summation of the all the samples S, the delta and epsilon is the notations or parameters of the hypothesis of the target function f of x into hypothesis of the function. This formula is calculated by the sample error concept. And the second one is the by using the probability distribution with the sample data, the true error, it is denoted by the using the sample is called as the sample error, true data error of the d of H, d is the distribution of the hypothesis H with respect to target function f and distribution d, which is the probability that H will be misclassify an instance drawn at random according to the d. Here the error d of H is equal the probability distribution d f of x is not equal to H of x. The sample function is f of x into the H of x and the true error is not equal to H of x. We calculated two different errors in sample data with hypothesis. And the next topic, probability approximately correct learning, simply called as a PAC learning. The simple meaning of the probability approximately correct learning is called as a learn of the data with correct hypothesis or probably approximately correct learning. We are defined the simple view of the PAC learning is particular setting for the learning system is called as a probability approximately correct learning. Why we need the probability approximate correct learning is we have the training data, this is the training data with the different classes, and we apply this some of the learning algorithms to process the hypothesis. In this case, now we define the probability approximate correct learning. This is a mathematical representation of the approximation with different training data, particular setting for the learning system. Some of the meanings, other meaning of the learning is the analyzing learning algorithms mathematically or the mathematical analysis of machine learning. Why we learn PAC learning is like how many training examples are there or how much competition are required. In these two questions arise when the PAC learning concept is learned. The main goal of PAC learning is with high probability with low error, that is the approximately correct or probably correct, that is a approximately identical to the hidden target concept with high probability and low error. This low error is equal to small error, that means approximately the correct value. That's why we called as a probable approximately correct learning concept with high probability, that means low error and small error. We are using some of the notations in why, because we previous slide we are discussed about mathematically learned concept. That's why we use some of the notations related to the PAC learning. First one is the X. First one is the X notation, set of all people, all population, all instance, each describe the attribute, for example age or height or weight. And the second notation is the target concept that learner needs to learn the samples. The C always define X belongs to 0, 1. Here the third one is the learner is denoted the L, have to learn, people who are striker. Here the C of X is equal to the C of X is equal to 1, that is a positive value, is called as a positive training sample, and C of X is equal to 0, it is called as a negative training samples. And the fourth one, the fourth notation is called as the hypothesis, possible hypothesis, also H X belongs to 0, 1. And the next notation is the probability distribution D, and the training samples are generated randomly from X according to the distribution D. And the last notation is learning algorithm is denoted by capital A. The total 6 different notations we are using in the PAC learning. By using the above 6 notations, we are defined the general definition about the PAC. A concept class C in probability approximate the correct learnable if there is an algorithm A which for samples drawn with an probability distribution D, and any concept C belongs to the target concept C with high probability produce the hypothesis H belongs to capital target concept C whose error is small. Based on this exam definition, the with high probability and the less error or small error is the main view of the probability approximately correct learning. And the next topic, the error of the hypothesis. The error of the hypothesis is a minimum or equal always, that is a true error. The previous concept also we are defined the sample error and true error. The true error is always denoted by the error of the D of H of hypothesis, H with respect to the target concept C, and the probability distribution D is the probability that H will misclassify an instance drawn at random at D. The definition and formalized already we are defined once again. The error of the D of H is equal to the probability of H of X is not always not equal to the target class of X. Here the training error is nothing but the sample error. In this example, the X axis we are consider as a height and Y axis we are consider as a weight, and the first rectangle is consider as there are number of the samples, we are taking the pluses and minus, and first rectangular is belongs to the one of the hypothesis, and the second one target concept C, and second one is the hypothesis. The probability of the C exclusive R of H is always less than or equal to epsilon. We are define some of the parameters here, that is the PAC model. In this PAC model we specify the small parameter epsilon and delta without these two parameters